Take a moment and focus on this impossible figure. At first glance, it looks like a solid three-dimensional object, but if you try to picture it in the real world, it simply can't exist. It's like a visual puzzle created by M.C. Escher, where perspective tricks your brain into seeing something that defies reality. Now compare it with this second image, a figure that could exist in our physical world without bending the laws of geometry. Back in 2001, researchers used images like these in a fascinating experiment. They asked groups of people, some with dyslexia and some without, to identify which figures were impossible. What they found was surprising. People with dyslexia were significantly faster at spotting the impossible objects. This hinted at a unique visual-spatial ability in dyslexic brains, the capacity to see the whole picture at once, rather than getting stuck on the details piece by piece. This experiment wasn't an isolated finding. Over the decades, many studies have begun to validate what countless dyslexic individuals have shared anecdotally. While reading and writing might be a daily struggle, there's often a surprising strength hidden beneath those challenges. One person described it like this. They could spin a mental model of a puzzle in their head, flip it around, and deconstruct it in ways others couldn't. It's not about superpowers, but rather a different wiring. A brain that naturally thinks outside the box, seeing the big picture rather than just fragments. Around 20% of the US population has dyslexia, and while their difficulties trace back to specific brain structures, these differences can also unlock powerful advantages. From an evolutionary standpoint, our brains aren't naturally wired for reading. Unlike sleeping or reacting to fear, there's no dedicated reading center in the brain because reading is a relatively recent invention, only about 6,000 years old. Despite this, modern science has uncovered how our brains adapt to this skill. When children learn to read, both hemispheres of their brains work overtime, expending enormous energy to decode letters and sounds. For fluent readers, this process becomes streamlined. Key areas in the left hemisphere, like the visual word form area, help recognize letters and words quickly. Another region responsible for phonological awareness breaks words down into sounds, like separating cat into ku, ah, and tu. Meanwhile, Broca's area helps us grasp the meaning behind words, connecting all these regions through a complex network of neural highways that process words within milliseconds. But in people with dyslexia, these highways often look different. Brain scans reveal less activation in the left hemisphere areas essential for reading, suggesting disruptions in the pathways that link letters to sounds. At the same time, dyslexic readers show overactivation in the right hemisphere, a sign they are working extra hard to compensate for these challenges. This rerouting makes reading more laborious, and it's not just reading that can be affected. Dyslexia can also impact grammar, working memory, and even math fact retrieval. For some, it's not a complete breakdown, but a slowing of these neural processes, which can make everyday classroom tasks feel overwhelming. One person shared how reading aloud in class triggered panic. Words seemed to float and slip away, while everyone else moved on. The experience of dyslexia varies widely, but it never reflects on a person's intelligence. Today, dyslexia is recognized as a hereditary neurobiological learning difference. Research shows that targeted instruction in phonology, syntax, and spelling can greatly help dyslexic learners succeed. Yet the reading brain is just one part of the story. Increasingly, research highlights unique cognitive advantages that come with dyslexia: enhanced reasoning, spatial processing, episodic memory, and creativity. Some dyslexic individuals describe having a complete mental picture that lets them make connections others might miss. This different way of thinking can shake up conventional problem-solving and inspire new perspectives. One high schooler stunned researchers by drawing complex images upside down purely from memory, a clear display of strong spatial skills rooted in the right hemisphere, which is linked to visual imagery and creativity. In another study, dyslexic people were better at spotting letters in their peripheral vision, and when college students were tested on memorizing blurred images, those with dyslexia significantly outperformed their peers. A 2022 study from the University of Strathclyde and the University of Cambridge suggested that dyslexic cognition is specialized for exploring the unknown. Given how common dyslexia is, this way of thinking may have been crucial in human adaptation, especially through collaboration among diverse minds. These insights are part of a growing movement to embrace neurodiversity, the idea that brain differences aren't deficits, but natural variations. Unfortunately, stigma and misconceptions around dyslexia still exist. The more we learn about differently wired brains, the better we can tailor education, foster collaboration, and empower individuals. Imagine how transformational it would be for a child to understand that dyslexia is not a curse, not a disease, but simply a different brain organization. Recognizing the constellation of strengths and challenges hand in hand can open doors to acceptance, opportunity, and celebration of the unique talents dyslexic people bring to the world.